Okay, in this video we are going to learn about an ellipse. What is an ellipse? Ellipse is nothing but an elongated circle. You have something like this. This is an ellipse. This is an ellipse, and anything. And if you compress a circle or if you stretch a circle, what you get is an ellipse. We have seen it like planets. They all revolve around the sun in elliptical orbits. So mathematically speaking, what is an ellipse? So it is defined this way. An ellipse is the locus of points in a plane such that the sum of the distances from two fixed points, which are called as foci or foci, you can say, and the length is constant. That is, if A is one focus here, this point A is a focus, first focus, and B is the other focus. So because of two focuses we have, we call it as plural foci or foci. It's the same thing. Now, the length from that focus to any point on this ellipse. In this case, you have here 8.01, or let us say it is 8.01. That's what I have here. And the other length from the second focus to the point on the ellipse is 4.24. 4.24. And that sum is how much? It is 12.25. So if I move this point D to a different location on this ellipse and add those two measures again, you'll have to get the same length. That's what is meant by this definition of ellipse here. He's telling about the locus. Locus means it is the set of all the points which are satisfying this particular condition of having the same distance. Okay, so I have a visual for this. Let us look at it. So now I have the same ellipse here in this slide. Now let us see what happens when it rotates. I have here now it moved from the previous point to, let us, up to this one. Now what is the measure here? It is 3.68, and the other line segment is 8.57. 3.68 plus 8.57, 3.68 plus 8.57. On adding, it will again give us 5 here, that is carries 1, 2, and again 12.25. The sum is going to be the same. So wherever the point D lies on this ellipse, the sum of the lengths of these two line segments is going to be the same, 12.25 in this particular ellipse. So if you go around, let us go around this ellipse, the point D is moving around. Now let me stop here at this point and see it is 10.36 plus 1.89. Add those two, it's going to be 12.25. So go further and again stop there. 8.99 plus 3.26 will give you the same 12.25, because it is the sum of the lengths of these two line segments. Okay, that's what is the definition of an ellipse. An ellipse is defined in this manner. Let me go. So an ellipse is the locus of points in a plane, means these points, D's, wherever the D is a set of all the points, such that the sum of the distances from two fixed points, like points A and B, called as foci, is a constant. So the length of AD here, that AD plus the length of AD plus the length of BD. AD plus BD is always constant. So this AD plus DB is a constant in any given scenario. Now we have to we'll look at some more words that are involved in this. We have to look at those vocabulary, like what is the center, the focus, the vertex, etc. So I have here an ellipse. Okay, the first one have major axis. So what is the major axis? Major axis, it is a segment that contains the foci of an ellipse and has endpoints on the ellipse, and it is called as major axis. So these two are the points, those are the focus, first focus and second focus, that is foci, and a line segment whose endpoints are on the ellipse. They are lying on the ellipse, and that line segment is passing through the two focuses, right? First focus and second. Hence, that particular line is called as major axis. Okay. Now, the center is the midpoint of the major axis. That is over here. That's the center. And next one is minor axis. What is the minor axis? This line. We have over there this particular line. This one you call it as the minor axis because it is perpendicular to the major axis and passing through the center. A segment through the center with the endpoints on the ellipse and perpendicular to the major axis is called the minor axis. Now, what are the vertices? Those are the endpoints. The two endpoints of the major axis are the vertices, and the endpoints of the minor axis are called as co-vertices. So in this figure here, I have the major axis. The two endpoints of the major axis are the vertices you have, right? Vertex 1 and vertex 2. And on the minor axis, those two endpoints are the co-vertex, the co-vertex 1 and co-vertex 2. So these are the basic vocabulary that is required in this ellipse. Now, we have equations of ellipse, like how we have for equation of a circle, parabola or hyperbola, and now this is a ellipse. We have equations in a different scenario. Sometimes what happens is this major axis will be vertical. In this figure, you have seeing it as a horizontal line. Sometimes it will be vertical. So the equation is going to be different. So let us look at such scenario. Now see, in this figure, you have the major axis that is horizontal. And in the second one, the major axis is the vertical one. Okay. So I have them separately here in the next one. The standard form of the equation of such ellipse is this: x minus h whole square over a square plus y minus k whole square over b square, right? Okay, now the situation here is the major axis is horizontal. Okay, now in that case, the center of the ellipse, this point C, is a h comma k. So we have that h here. I'll bring it up over there. This h comma k gives you the center, and to get the foci, the first focus and the second focus, if I subtract c, h minus c comma k gives you f1, and h plus c comma k will give you f2. Those are the two focuses. Now the vertices h1 minus a comma k and h1 plus a comma k. Those are the two vertices you get there. And co-vertices are h plus h comma k plus or minus b. That is, you add b one time and take away b, so that you will get the other values, co-vertices. And the major axis is y equal to k. See, on this y-axis, this point, that value is going to be k. because you know this center is h comma k. If the center is h comma k, what is the y value here? That is k. The y coordinate is k. So y is equal to k is the major axis. Similarly, this is h here. X equal to h is the minor axis. So the equation of the major axis is y equal to k, and the equation of the minor axis is x equal to h. Now, next thing is ABC relationships. They are related in this way: c square equal to a square minus b square, or taking square root on both sides, c is equal to square root of a square minus b square. But where do you find those a, b and c in this? A is the distance from the vertex to the center on this major axis. This length is A. And B is from the co-vertex to the center, right? Vertex to the center is A, and co-vertex to the center, that is a B. And C is the distance from the center to the focus. So this length, this distance is C. Even this side also, from the center to the focus, that distance is equal to C. Now the relationship between this A, B and C is C is equal to square root of a square minus b square, or c square equal to a square minus b square. And always this A is greater than B. Okay, A will always be greater than B. Sometimes, suppose if you have b square here instead of a square, what happens is the graph of this ellipse from the horizontal, it changes to the vertical. We have it in the next slide. I'll show it in a second. So here the equation of the ellipse is x minus h whole square over b square plus y minus k whole square over a square, that is equal to 1. Just that a square and b square, they switched their locations. So that's the reason the focus 1 and focus 2, they lined up vertically here. Hence you have a vertical major axis. The graph is just turned around from horizontal, it is moved to vertical. So these are the V1 and V2 are the vertices, and the other two here are the co-vertices, and you can get their values from this equation. Like center is the same, h comma k, the foci is h comma k plus c and h comma k minus c. That gives you the first focus and the second focus, and the vertices, that v1 and v2, you can obtain by using these coordinates h comma k plus or minus a. Similarly, this major axis, because it's a vertical line, you have x equal to h, that is the equation of the major axis, and the minor axis is the horizontal one. So equation of the minor axis is y equal to k, and the relationship between a, b and c is the same thing, c square equal to a squared minus b square. So this is all about an ellipse. The definition of ellipse, equations of ellipse in two different forms, and number of terms that are involved in this, that we have seen all those. And in the next video we are going to look at few examples. Okay, thank you. Thanks for watching.